So you can see that this is the box plot of a normal distribution, and this is the box plot for positively skewed. Okay, quartile 3 minus quartile 2, it is greater than quartile 2 minus quartile 1. And this is the data for negatively skewed. Quartile 3 minus quartile 2 is less than quartile 2 minus quartile 1. Okay, so this is negatively skewed. Okay, so you can definitely you can understand from your box plot that how your data is distributed and whether how close it is to consider to be a normal distribution. Okay, so this is about the how to understand these are known as, actually all these things are known as the normality test. Okay, how your data is distributed. Okay, so but now I would like to discuss some very basic concepts. Okay, because in many cases we do not know or we forget the basic concepts. Okay, what are the basic concepts? The basic concepts are what is actually, whenever we talk about histogram, distribution, bar chart, frequency diagram, okay, or what are these things actually? Okay, so I'd like to tell you that first I would like to say about what is the distribution. Okay, distribution of a statistical data set or a population is a listing or function showing all the possible values or intervals of the data and how often they occur. So this is actually known as distribution. Suppose you have been given a statistical data set, and along x-axis you will represent the outcomes, that how, and along y-axis you will check that how frequently you are getting your all possible values or the intervals. Okay, so that is actually known as your distribution. Okay, or this is for the population. Okay, or for any statistical data set. Okay, so now we can see that there are basically two different, there is a lot of distributions. Okay, but broadly speaking, there are two different types of distributions. One is a discrete distribution and another is continuous distribution. Okay, you can see that binomial distribution, Poisson distribution, these are discrete distributions, while the exponential distribution, Weibull distribution, normal distribution, Z distribution, students T distribution, chi-square distribution, F distribution, these are continuous distribution. Okay, why these are discrete distribution? These are discrete distribution because along x-axis, in this case, you represent the discrete variables. Okay, along x-axis, you can see that along x-axis, this is a discrete distribution, this is a continuous distribution. So along x-axis, whenever you deal with the discrete distribution, along x-axis you represent discrete variable. For example, suppose if you throw a dice, okay, it can be either 1, it can be either 2, 3, 4, 5, 6. These are the outcomes. Okay, but it cannot be 1.5, 1.7, 2.9. This kind of outcome is not possible. So that's why they are represented by, these kinds of variables are represented by your discrete distribution. Okay. And in case of continuous distribution, suppose you are representing the heights of the students, it can be any value. Okay, suppose you are representing in centimeter, 175.13, 168.29, 179.37, 178.21. So any kind of values are possible here. So that's why for the continuous, these are known as continuous variables. So that's why for the continuous variables, when you will be dealing with the continuous variables, or when you will be representing along x-axis the continuous variables, you will be saying that you will have to use the continuous type of distribution. Okay. Now, keep in mind that in case of discrete distribution and also in case of continuous distribution, along x-axis we are representing the outcomes. Okay. Suppose there the data set is given, so you know already the outcomes are actually being represented in a data set. Okay. But what you are representing along y-axis, that is the question. In case of discrete distribution, along y-axis you are representing only the probability. Okay, that what is the probability of the 3, that if you throw a dice, the value of 3, what will be the probability of it will come out to be the value of 3. Okay, so only the probability you are representing along y-axis. Okay. But whenever you are saying about continuous distribution, you are not representing only the probability, you are representing actually the probability density. Okay, you are representing the probability density. Okay, and suppose why you are doing that? Because your discrete distribution, it is actually based on the frequency diagram. Okay, it is based on the frequency diagram. But whenever you are saying frequency diagram or the bar chart, you can say. In case of bar chart, you basically represent different categorical data. Okay, here you are actually not representing the categories as such. Here in case of distribution, you are actually the outcomes you are actually representing, but still it's more like a bar chart or frequency diagram. Okay, but the concept of continuous distribution, it is based on the histogram. It is based on the histogram. Okay, and what is histogram? So histogram is actually some particular ranges are suppose here you can see that this is actually known as a histogram. Okay, this is here actually they are mentioning it frequency because they have taken all the equal interval, but actually in case of histogram it should be frequency density. If that they take not the any equal interval, then it will be treated as histogram. You just have a look at this one, the concept will be clear. This is the histogram. Okay, suppose in case of, suppose you are representing a bar chart. Okay, so in case of a bar chart, suppose if you represent that how many students, what percentage of students belong to the engineering department in VIT, what percentage of students belong to the business school of VIT, what percentage of students belong to the law school of VIT. In this way, if you represent all the percentages, it will become a bar chart. Okay, and in case of bar chart, there will be a gap. Okay, there will be some gaps. Okay, but in case of histogram, there will be no gap, and the frequency will be represented not by the height of the bars, but it will be represented by the area of the bar. Okay, it will be represented by the area of the bar. So along y-axis you are representing the frequency density you are actually representing. Okay, why? Because suppose you are taking some interval here, suppose the height of the students, okay, suppose from 140 to 150 you would represent, then 150 to 170, then 150 to 160, then 160 to 180. Okay, so you can understand here, if you have a look at this particular histogram, you can see that these ranges can be anything. It's not like the ranges will be equal in all the cases. The ranges can be different. Okay, so the one particular thing will actually represent the density. Actually, one unit will represent not just the frequency, but the frequency density it will represent. I'm trying to show you one example was there. I'm not getting that example. Another example we can see. Okay, so now I can show you one very good example. Yes, I've got it. You can see that different, here you can see that different ages are given. Okay, 36, 67, 25, 45. In this way, different ages are given. This is a data set. This is called a data set. Why this is a data set? Because all this data are representing different outputs. Okay. Now, if you want to show this data set with these unique values, it will become very difficult. Okay, for suppose there are lot of data are there, so this much of data points you need to show along x-axis, so that is not possible. So that's why what we can uh, do, we can create a range like 20 to 30, 30 to 40, 40 to 50. This way we can create a range. Okay. And we can see that what are the frequency in that particular range, what are the frequency of those data. Okay. Now, for example, suppose I have taken this kind of class width. Okay, one is I am taking 65 to 75. This I am taking one range. 75 to 80. This I am taking one range. 80 to 90 is one range. 90 to 105 one range, and 105 to 110. This is another range. So the class width is 10, 5, 10, again 15, because 105 minus 90, 15, 105 to 110 is 5. And the frequency of the data, 65 to 75, there are two data in that particular data set. From 75 to 80, there are 7 data set. Okay. So now if you plot what will be the frequency density, if you divide it, 2 divided by 10, then it will become 0.2. Then again frequency density, if you divide 7 by 5 is equal to 1.4. So in this way we can calculate all the frequency density. Okay. So now if you plot, if you can see that different colors are used to represent different class width. Okay. So automatically you can understand that the height, okay, of here, the frequency is actually represented by the area itself. Okay, from 65 to 70. Okay, so you can see here that suppose from 75 to 80. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so you can see that 14 means suppose this is 1.4, because it is you are dividing it by 10. Okay, because there are 5, you are taking one each row as 0.2. Okay, so here the total area, it is actually representing your the frequency it is representing. So this height, it cannot represent the frequency. This height is definitely representing the frequency density. Okay, this height is actually representing the frequency density. So based on this concept, based on the concept of histogram, actually you are getting the concept of the continuous distribution. Okay, so that's why whenever you use the continuous distribution, you don't represent the frequency, the probability density, rather you don't use probability, you use probability density. Okay, there is another easy way to understand the concept that why we use probability density rather than only the probability. Okay, there is an easy concept, I will tell that. Suppose, for example, you are asked that you based on a continuous distribution, you need to find out that what is the probability that a project will be the project will be finished by 45 days. Okay, so when you are when you want to find out the probability that you will be, suppose you're here, there is one particular line uh, that is representing your 45 days. Okay. So in that case, from that particular line, from the minus negative, from infinity to up to 45, that particular area you need to consider in order to find out what will be the probability for that the particular the project will become completed within that particular uh, day. Okay, so I can show you one another example. It's like that. uh, it's not a very good example. Okay, I can show you here also. Suppose this is the normal distribution. Okay, now instead of here it is marked in red values. Okay, now suppose here the red value, it is the shaded portion is here. Okay, suppose you think that the shaded portion is here, not here, and this particular y-axis, it is representing your 45 days. Okay, and your mean value is suppose 43 days. Okay, now if you are asked that what is the probability that the project will be completed within 45 days, then how you will find out that value? You will actually, the total area under this particular curve, you will be finding out, to find out that what is the probability to complete the project by 45 days. Okay, that means the project may be completed on the 43rd day, 42nd day, or 44th day. Okay, so those probabilities you are also calculating. And whenever you are saying that the project will be completed by 45 days, you are basically considering cumulatively, because the 45 days, it also includes so it also incorporates the 42nd value, 43rd value, 38, 39, all these values it also incorporates, because the project may be completed earlier as well. Okay, but whenever you are saying that what is the probability of that the outcome will be 3, if you throw the dice, it will not incorporate the values of what will be the probability of 2 or what will be the probability of 1. It's not like that, because they are independent of each other. All the outcomes, they have no relation in between. Okay, in this case of the project completion date, there is also no relation as such, but it may take less days. Okay, so that's why it is said, that's why it is the easier way to understand that why we consider along for continuous variables, we consider along y-axis, we consider the probability density rather than the probability. And if you integrate this function within a particular range, okay, then you will get the value of probability. That means that area will represent the value of probability. And that's why when you consider, suppose if you are asked what is likelihood, okay, for the discrete distribution, the probability and likelihood are the same. But whenever you are asked what is likelihood for the continuous distribution, in that case, for continuous distribution, the y-axis value, it represents actually the likelihood. That means this probability density, it represents the likelihood. Okay. So your question should be that what is the likelihood that the project will be completed on 45 days, on 45th day. Okay, so if you ask this question, that is okay. But if you ask that what is the probability that the project will be completed on 45th day, that question is actually meaningless. That question is wrong. Okay, because whenever we will use the probability concept, we will have to say that what is the probability that this project will be completed by 45 days or within 45 days. Okay, because you are considering a range, cumulative values you are considering. Okay, but whenever you are for continuous distribution, but for discrete distribution, it is okay, there is no problem. But and whenever you will ask about the probability, likelihood is nothing but conditional probability. That means some particular data will be given to you, or the outcome will be given to you, that suppose 45 days, that is the date that is given to you, and you will be saying that what is the likelihood of that particular of the finishing of that particular on that particular day. It is not by or within that time, it is on that particular day of 45th. What will be the probability? That is actually known as the likelihood. So it is basically conditional probability. Okay, so hopefully these things are clear. These are the very basic statistical concepts. Many times we get very confused about the basic concepts. Okay, so this is also in discrete function, in discrete variable or discrete distribution, the y value in the y-axis represents the probability, or it is also termed as this function is also termed as probability mass function. Here in this case, it is termed as probability density function. But in that case, it is the continuous case for probability density function, and in discrete distribution, that is known as probability mass function. Okay, so I'm going to stop.